Welcome to part 4 of our Kornucopia ML Quick Start training. This is the fourth of 8 videos for this course. Please visit our website at boditech.com for additional details on downloading the accompanying PDF course notes and any other training files. Next, we will discuss additional Kornucopia syntax features beyond those related to the KUnits data type. I'm going to go over some highlights. There's a lot more additional information than the highlights I'm giving you in the help system. So, if what I'm giving you isn't sufficient, I encourage you to look at the actual help pages on these different topics. What you will see when you open up examples and start to work with Kornucopia is you will typically see these 4 commands somewhere near the top of the file. The cleanup one I've used already, and the units preference activate one I've used. I'm showing you the units variables, and there's this additional one, ADV equals K_ADV. You haven't seen that yet, and we'll be discussing that very shortly. So the whole idea with the cleanup is if you click yes, it's going to do these 3 actions for you. If you click clear only, the middle button, I've yet to click that. What that will do with clear only is it will not close any figures. So it just does clear variables and the home. So it cleans up the command window, but it doesn't close any existing figure windows. That becomes really useful when you're running another script, but you want to compare results to a figure window you have. You don't want to blow that away. So you would pick clear only. And if you pick no, then it's not going to do any of those things, and it will just kind of ignore the cleanup request. The units preference activate when you're first doing this. In a script and you're not super familiar with the unit preferences, putting in the question mark gives you this selectable list. I already showed this. Once you select something, it'll echo it to the command window, and then you should copy it and paste it in here so that it's then in your script so that you don't keep having to do this every time you run the script. And the unit variables, you use those as you need. Some scripts you won't have any because everything will be read some data and do some manipulations. Others, you might be making a variety of KUnit variables. And this advanced options variable, so that's what we're going to describe right now. So Kornucopia ADV parameter. So nearly every function in Kornucopia will have an argument list where you have the function name, some number of arguments, and then the list will end with ADV. So ADV is just representing that there are additional potential advanced arguments that you could put in, or you could put in none of those and just put in the primary arguments. When you supply appropriate ADV arguments for a given function, you then can control more the behavior of the function. When you don't, you're taking the default behavior of the function. Each function has its own ADV parameters. And all ADV parameters are a combination of a parameter name, also known as a keyword, and a parameter value. So obviously, you must put the parameter name first, then followed by the parameter value in the function call. But the list of these pairs can be put in any order. So you might call a function where you call 3 or 4 different parameter options, and you can put them in any order you'd like. And Kornucopia will handle that with no problem. If the same parameter name is put in twice in the list, whatever the last one in the list is, that's the one that will be governing its setting. And the Kornucopia help page has complete detail for every function and its parameters. Let me quickly show this live in MATLAB. A function that some of you will be using, especially if you're in the simulation world, will be K_regularize. So here, if I do the quick help on that, and then say open up the detailed help page on that, it will go right to that spot in the help system. And now I can look at this K_regularize function and learn all about it. So here there's a little bit of English describing its general use. Then it's giving you the syntax calling choices and what all the arguments are, and then it has this list of advanced arguments. So these are all keyword value. Sometimes the value is a string. There should be a quote here. And sometimes they're just numbers. If I click here, I will go to an additional page within that talks all about that. And every advanced option will be described, what it means, how you use it, what settings can be put there. So the help system has all that information to guide you to use these advanced options successfully. So let's kind of look at this K-regularize thing I just demonstrated. Typing this, clicking F1, getting the help, and then clicking on the help page, and then scrolled down into the help page and saw this list. And then we went to additional things and I showed you that. A really cool thing also in Kornucopia, you can take any function and in the command window, if you just give this single argument, it will echo into the command window the advanced options. So if I type here in the command window and do this, putting in -ADV, it'll echo in the command window this quick thing that describes all the parameters, the param names, and the things you could put in there for them. So as you get used to using the software, you can either go look in the help and read about it, or you can use this quick little thing to get a quick list of the advanced options for functions. The third approach is going to be by this ADV parameter. Let me show you calling this regularized function, which normally asks for either XY data or XY data together, and then overriding its call with some advanced options. So here would be a call to the function with no advanced options. Here would be some calls to the function, and I'm using this second format here where I give it the data all together. I skip the second argument. And then for advanced options here, I'm changing how it's going to interpolate when it regularizes. By default, it uses a splining method. I'm saying use a linear method. And when it regularizes data, it's got to come up with some value of the representative interval of the normally time increment or whatever's in the first column here. So instead of using the mean, I'm telling it to use a standard deviation method to determine regularization. Here in the second example, I'm controlling a relative tolerance that's used to determine when the time increments or whatever this column is, when the increments are not constant. It has some numerical tolerance. We're changing that. Here I'm referencing that I don't want the first column, which happens to be time, to be the independent thing for regularization. I'm referencing I want it to be the external or extension column. And then here I'm changing an assumption on the spline function that's being used internally. All these things are described on the help page. The point is you can, do various flavors that you want to control the function as you need. Sometimes the parameters that go along with the param names, so the param names are always strings. The param values could be numbers, sometimes they're strings, they might even be cell arrays or other data types. It depends on the particular advanced option and the particular function. You can also do things like type short any parameter name. So here the parameter name was typed as independent call, which is the full parameter name. Here I just type independ. So I can type any of them short I want. All I have to ensure is I have enough letters here that for the parameters that this function knows about, that it's unique. As long as it's unique, Kornucopia will interpret that. I had previously said we have this ADV function, which we would typically set to this variable ADV. And you would generally put this at the beginning of your script. The reason you do that is this is going to generate a very handy variable that's of a structure type whose field names are all Kornucopia function names. And as we further go into the fields, you'll get all the advanced options and all the advanced possible settings. So if I make this command and then in the command window say what's ADV, it shows me as a structure. The structure has fields that magically are the same as the Kornucopia function names. Similarly, in the command window, if I type adv.k, I could start picking one of these. And this list, whether you look at it from here or here, looks exactly like the list of function names themselves. So what that allows us to do is something like this. Using .tab notation, I could say adv.k underscore, and if I scroll down to like k underscore regularize, right? Then adv.k_regularize will show me all the param names that are possible. And then if I continue dot and some particular param name, I get the actual settings to choose from. And if I actually picked one of them, it would return a keyword and a value. So the way this looks live is like this in MATLAB. So I'm just gonna say adv k_adv. I'm just gonna execute that. So now there's this adv variable. So now I could do k and I can scroll down. If I type RE, it'll start getting me down to regularize. .tab, these are the options. So if I pick interpolate via, that's what we picked, .tab, I can say I want to interpolate using just clean the data, don't actually interpolate, using a linear interpolation or a spline interpolation, or whatever the current value is for this setting. So now if I execute that, that really returns a keyword and a value. The beauty of this is I can do now this kind of thing, which I will show back in PowerPoint. Here I'm regularizing the data and I'm typing in the keyword, the value, the keyword, the value. Here I'm doing the exact same thing, but for this keyword, like maybe I don't know what that is. I didn't want to look it up in the help system. With the ADV variable, I would just type adv.kregularize, .tab, I'll pick this, .tab, I'll pick that. And that there would effectively put this in here and it will work just like this. So what you will find is you'll find various examples that will use this kind of approach sometimes, and sometimes this kind of approach, or mix and match. It's just multiple options for you to be able to control putting advanced arguments into your functions. The syntax is very, very flexible, and you can utilize a variety of forms. And I find, and other people who use Kornucopia, once they learn about this, find this as a quick, easy way to get at what are advanced options for all the different functions that are in the toolbox. The next flavor of syntax that I want to talk about is this flexible XY data input syntax. You will see on a variety of Kornucopia functions that are expecting some kind of X and Y data, like for integrating, taking a derivative, filtering, plotting, regularizing, a whole bunch of different actions. Here we're doing curve fitting. The functions are always shown with at least two kinds of syntax. One where it's give me the X data and then the Y data, and one where it's all combined as one array and skip the second argument. So the two argument approach, which is like the classical approach, you're more than welcome to do that. But you'll find that when you do that, a lot of times you end up having to do a lot more manipulation of variables and stuff because you're constantly keeping track, separating the X and the Y data. It's very common that X and Y data comes in as an array together, and then you can just keep it that way throughout all your manipulations using this second one input argument or the XY data format approach. And then Kornucopia will naturally work with the data in a very smart way. You even have the flexibility in this through an ADV option to control what is deemed to be the independent column or the X column of your data set. By default, it would be the first column of the data set, but you can change that with an ADV option. And when you use this, you need to remember that you will generally have to put an empty square brace in the second argument so that any additional arguments that appear after that are in the correct location in the function call. Example with k-regularize using flexible input. So here's an example where we have a vector t and a vector v, and here we're concatenate them together to a single array called raw. So this is some number of rows in one column. This is some number of rows in three column. And then here we've got some other goofy thing where our independent variable t is not the first column, but happens to be the last column. MATLAB would show the quick help like this, but if you open up the help in Kornucopia, you will see that you'll always get multiple options, including this XY data option. If we then use that, with this, we would get something like this. With 2 arguments, to regularize it, you would feed in T and V and you get the regularized version back out. If you had combined it as 1 argument, like here, then we can just feed the raw in and you get the regularized version back out. This, to me, is easier syntax and is more natural with working with data. And if you did the goofy version, where the time axis was not the first column, then you have to tell the software which column is the independent column so it regularizes against the independent column correctly. The bottom line, for typical cornucopia workflows, most people will use the 1 argument XY data format, but this is up to you. You can choose either way you want to do that. Okay, the last piece of syntax discussion is related to smooth, curly, and square braces, plus comma, semicolon, and colon. These syntax components sometimes confuse people in MATLAB. So this little 1-page description is to try to help clarify that. Some people who do not do a lot of scripting might view this like lions, tigers, and bears, oh my, a quote from The Wizard of Oz. So if you use smooth braces, in MATLAB, those are used to reference an element in an array. So if you have some array and you do A 3, 2, you're getting the 3rd row, 2nd column, you're getting that element out of the array A. And that'll be the same data type as whatever A was. So if A is doubles, you get back a doubles. If A was a K units data type, you get back a K units data type. Curly braces, a general use of curly braces is you're stepping into and getting or placing content from or in the element itself. So if you think about cell arrays, when you use a reference like this with curly braces, you're stepping into the cell array and getting the contents out at row 3, column 2. If you had used smooth braces, you would get back out a cell array itself. You would be just cutting that part of the cell array and taking that as a cell array. Where here you're stepping into the cell array and getting whatever the contents are in the cell array out in their native format. In a MATLAB table, the curly braces are used to get at the numeric data of the table or whatever data is in the underlying table. Kornucopia doesn't use that for the data. It uses .data instead to get the numeric data. Kornucopia will use curly braces currently only on the left side, and that allows you to, when you do calculations, to keep the properties and the units that they were originally on the left side when you replace something from the right into a particular column. This is a kind of abstract concept right now. If you're just learning, this might be a little bit over your head. So don't worry about that. And as you start to use Kornucopia, you will probably stumble on this at some point. Square brackets in MATLAB are used to concatenate scalars, vectors, and arrays to make larger arrays. And they're also used to delete rows or columns or to make an empty variable. And then the comma, semicolon, and colon are usually various forms of delimiters, but there's several other syntax that are used in MATLAB. And for Kornucopia string lists, these are forms of delimiters. That concludes part 4 of our Kornucopia ML Quick Start training. Please continue with the next video, part 5, via the link provided on our website.